Hello and welcome to the Road to Autonomy. The Road to Autonomy is brought to you in part by Stantec Generation AV. Stantec Generation AV combines some of the most experienced AV experts in the industry with the resources of a global engineering firm. Stantec Generation AV provides education, consulting, assessment, and guidance to any industry interested in autonomous vehicles. Learn more at stantec.com. Hello and welcome to the Road to Autonomy. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to have Qasar Younis, CEO and co-founder of Applied Intuition, and Peter Ludwig, CTO and co-founder of Applied Intuition. Gentlemen, welcome to the podcast.
Thanks for having us. It's great to be here.
Super happy to have you here because simulation plays an absolute critical role in enabling autonomy, and I can't wait to dive into this. But before we do, I'd love to know, Qasar, when you first laid out the plans for Applied Intuition, what did you see in the marketplace?
Yeah, this is now 4.5 years ago. So, the timings, it's been a little bit, especially in the tech business. I mean, 4.5 years is a long time. And Peter and I really started thinking about this, obviously, much sooner than we even started it. I think the key point would be there's just a lack of good tooling within the business. And when we say within the business, we mean autonomy, we mean automotive, we mean, the general mobility space. So that kind of started us down the path of what became Applied Intuition.
Putting this all into context, you mentioned years ago, Applied Intuition, you were founded in 2017, and that was the same year that Waymo first started testing autonomous minivans without a safety driver on public roads in Chandler, Arizona. The market was starting to mature then. Why then was the time to launch Applied? Was it the lack of really good tools, or did you see something more in the marketplace?
Yeah, I think that certainly Waymo is a pioneer in the field, and they are, I think, showing the world what is possible. But of course, Waymo is just one company, and Qasar and I both have pretty deep backgrounds in the automotive space. And generally speaking, there's not really winner-take-all dynamics in the automotive ecosystem. There's always going to be many companies, there's going to be many players, and I think Waymo being sort of in front in autonomy technology, what's great for Applied is they are showing the world what's possible. And then we're building tools which, frankly, enable any automotive company to compete at that level.
Peter, from a technical perspective, what was the state of simulation in 2017?
So, of course, simulation is not a new field by any means. And in fact, simulation has many, many subcategories. There are public companies that literally own portfolios of dozens of different simulation companies. So when we're talking about simulation, we're talking about it within the context of building autonomous systems. And in 2017, there, of course, were many simulation tools for things like vehicle dynamics, right? Developing the chassis and the mechanical systems of vehicles. But what was lacking in 2017 was a great simulation story for developing software for autonomous systems. And that's really the market need that we identified. And that's what we've built our tooling around since 2017.
You've built great tooling. And several of your clients are friends of mine, and they say you're the absolute best simulation software out there. So they're great people, and I trust them. So I put a lot of faith in what they say. Peter, 2017 was 4.5 years ago. How has the simulation market matured and evolved over the time? Is it just constantly you're making your product better and better and better?
Absolutely. Simulation is a field where the depth of features matters a lot. And so certainly when we were starting in 2017, at that time, our tools were early. Now our tools are really quite mature. They're used in production by many companies globally. The feature set is very deep. And of course, we love working closely with our customers and understanding exactly what their technical needs are. And so since 2017, we've just made our products better and better to really serve our customers really well. The feature depth at this point is incredibly robust and deep, and user manuals are very extensive. You really can use our tools right now off the shelf to build a production track autonomy system.
Yeah, and I think also, to answer that question of how the market's evolved, I think in 2016, 2017, the only pattern was the Waymo pattern, which is raise tons of money and build everything in-house. And that's just not the case anymore. I don't think there's a single sophisticated in-house sim team that isn't also working with somebody in some capacity that's not inside. Because frankly speaking, this is not the case for all things in autonomy, but in simulation, it's quite simple. The needs that you have between companies and between use cases are quite similar. And so it's just economically more feasible to buy. So let's just say roughly it takes 100 software engineers, 2 years to build a good foundational product in simulation. Well, if you do that in-house, that costs X dollars, and you can buy that off the shelf for a fraction of that cost. And that's why the supplier ecosystem is robust. Nobody thinks Bosch is challenging Daimler, right? And that's why there's a symbiotic relationship between vendors and the kind of main players. That's kind of what we're emulating in that sense. Is we can support our customers, and I think that's changed. I think we had more resistance 4.5 years ago to buying tools, and now I think very, very rarely do you get anybody who's scratching their head on the build buy. They're really looking at feature sets and can we accomplish those things. And Peter mentioned it, just because we've been around, it's not our genius. It's just we've been around and we've made our tools better and better and better. And I think that's allowed us to have this kind of category leader position that we're obviously very, very keen on keeping and building on.
And furthermore, there have been a number of technology advances which have allowed us over the past 4.5 years to, I would say, close that sim to real gap, which is often spoken about in simulation, where, of course, you want the simulation to be as close as possible to the real-world performance of the system while still being cost-effective to run. And we've certainly seen great strides in that over the past 4 years, I'd say both through our own internal developments and our own technology, and then also through greater availability of particularly advanced hardware from companies that are building chipsets. And we've been able to utilize that latest chipset technology to do some really interesting and innovative things.
Did you run into any supply chain constraints around the chipsets and shortages?
I would say it's definitely affected us a bit in the extent that I think the global chip shortage has definitely affected the GPU and the parallel computing industry in the sense of, let's say, the availability of GPU compute at the major cloud providers is somewhat constrained. Also, just imagine building an on-prem cluster and you're placing orders for various components, and there's just a long backlog for certain components. So we've seen that to an extent. I would say, though, it's certainly not affecting us to the extent that it affects companies that are, for example, selling vehicles and they have to stop production lines.
That's fantastic. And you hinted at this and you've lit around it, but you have leadership. You're not only building the world's best simulation software for autonomous vehicles, you're taking a really important leadership position. You recently published the Best Practices Guide for the Testing and Deployment of Autonomous Vehicles. Qasar, really well done report. To me, it says leadership, leadership, leadership. Why did you decide to do it now? What did you see, and why was it really important for Applied Intuition to publish this guide?
I mean, we just the nature of our business, we have lots of autonomy experts inside the company, and you can define that in many ways, whether it's through academic experience, whether it's through published research, or obviously industry experience and deploying vehicles. I think at this point, we probably have somebody from every major, academic institution and program in the company. And so you end up just collecting a lot of knowledge. If you're one company building AV in one way, that's one perspective. But because we work in construction and mining and defense and agriculture and traditional robotaxis and automotive and commercial trucking, you just learn a lot about autonomy. And so, we wanted to share that. Our interest, our goal of the company is to move the entire autonomy ecosystem forward. Before, and we say it often, we don't cheer for anybody to lose. We want the entire industry to win. It's not our incentive at all to see any one company fail. And so we want folks to have the resources and the ideas to make sure they're not wasting their money and their time. And if we can put that into a 20-page report and publish it, that's great. I think that's the evolution of every industry. Initially, everyone hoards this information like it's some gold. And then ultimately, it just becomes common best practices. And you've seen this in web applications. You've seen this in mobile app development. Every industry goes through this. And so there's a kind of a generally understood best practices. And we just actually just wrote them down and published them.
And furthermore, I would say we do care deeply that these systems globally are being developed safely. And our best practices really are around the aspects of how do you develop these systems both safely and cost effectively. And of course, our tools can be used for parts of that. But there's also many aspects, of course, that it's great to work with other companies as well. We did put a link to the best practices guide at applied.co/the Road to Autonomy. So for any listeners that would like to see the guide, go ahead and go to applied.co/the Road to Autonomy.
This is Peter and I watching enough YouTube videos where Squarespace gets shout outs. So we thought, Grayson, we would do a URL for your show.
I really appreciate that. I read the guide. It's really good. Applied.co/the Road to Autonomy. Knowledge is cool. I want to go to Applied University. So I can't wait to see what you've got all these incredible individuals, these degrees series. I can't wait to see what guide you publish next, or perhaps you do an Applied University video series on YouTube, because I can't wait to watch that. Qasar, taking a step back for a moment, how would you describe simulation and the role it plays in enabling autonomous vehicles to scale safely?
So, we're speaking at a very, very high level here. Kind of fundamentally, there's a near infinite number of scenarios in real world driving, and you have to figure out how to systematically test and validate around edge cases and where your system and the sub-modules we're talking about, so it's not even the overall system, but let's say your perception module or your planning module are failing. And so if you look at, again, Waymo being like an industry benchmark to some degree and leader, there was an interview by their senior director of product management. And what they said was, roughly speaking, its simulation is responsible for 80 to 85% of our progress. That should be something that really, echoes in the head of anybody who's building autonomous systems, that you really want a simulation first approach. But what's difficult is it's just very expensive. I remember when we were starting the company, the founder shall name unnamed, but a well-known AV company that is not Waymo's founder said, well, this is so difficult. Why wouldn't you just build an AV company directly? And we thought of the same thing, but we just thought in the opposite way, which is, this is so difficult, we can build it for everybody. This being a simulation suite of tools. And so I think where it becomes challenging is when companies try to do everything. And I think there's a limited amount of resources. I think it's been very sad, for the lack of a better word, where you've seen companies, fall and get acquired, or frankly shut down because they've run out of resources. A part of that is, how do you allocate? But at the highest level, it's this concept of, there is this near infinite number of scenarios, and how do you get through them? And then how do you develop your system in a almost mechanical way? I don't know, Peter, if you wanted to add anything to that.
Yeah, I think that captures it really well. Fundamentally, there are many things that you cannot test safely in the real world that are necessary for ensuring the safe operation of the vehicle. And you can model those scenarios in simulation.
Peter, that brings up a really great interview you did with Bloomberg in 2018, where Mark Bergen, the interviewer, stated the following in the article about Applied. Self-driving cars have made virtually every mistake imaginable inside the office of Applied Intuition. One braked hard to miss a pup that had to run into the street. Another barely avoided a truck with a blown tire barreling down the freeway. I want to know, I think this is cool, how do you and the team come up with these scenarios? You sit in front of a whiteboard and think of the craziest ideas and then put it into simulation. Could you shed some light on that, please?
Yeah, absolutely. It's important to understand, though, that scenarios are very customer specific. And fundamentally, our tools, they are enabling our customers to build the scenarios that are important to them for their use cases. And so, as an example, a company that's developing a self-driving truck, they're frankly going to care about different things than a company that is building, let's say, a robotaxi application. There are just different things that are more likely to occur in each of those operational design domains. And so, as a part of our offering, we do offer, think of them as scenario packs. Sets of scenarios that are relevant to different operational design domains, but that's generally a starting point and not a final point. And our tools are really enabling our customers to also build their own sets of scenarios. But in terms of the actual source of those, of course, there's many ways to come up with scenarios. One way would be literally experts sitting down and doing more of a scientific analysis of what's possible in that particular ODD. Another way is using the drive log data that you've collected from the real world and then analyzing that data for those interesting scenarios. And there's many other ways as well.
So I want to give you a scenario here. I live in Palm Beach, and once a week, this truck with a crane and a follow truck goes and picks up all the palm leaves off of them and puts it in there. Is that a scenario that you can put in simulation so vehicles start running on Palm Beach Island? Okay, they know every Monday the palm tree truck comes. This is how you avoid it and how you get around it. Would that be a scenario that could be done in your simulation?
Absolutely, yes. And in fact, we've had customers build scenarios that are similar to that for many different operational design domains. I would say
for that company, Palm Beach Autonomy Vehicle Company.
I would say, yeah. Furthermore, there's many interesting scenarios around things that temporarily affect road structure. And so construction is one example. Bad weather, imagine a flooded road. That's another example. There's many examples like this.
Okay, I'm going to stay on the local scenarios here because we're undergrounding our utilities now. So is that another scenario that you could put there? Say, okay, the construction trucks operate at these hours of the day and it's going to take 4 years?
Absolutely. Yeah. Construction is, frankly, one of the most challenging parts of building an autonomous system if you intend to navigate safely around the construction. Many companies today, they use databases from city governments and they blacklist the areas where construction is occurring such that autonomous vehicles will avoid that area completely. I don't think that will be the end-all be-all state, though, of these systems. systems. As the ODD is expanded to include those construction areas, modeling them in simulation is very critical.
Qasar, what Peter described sounds like to me is one of the key benefits of simulation. Am I right on that?
Yeah, absolutely. I think that's the case. Also, it's you just can't create all these scenarios in real world. Let's say you didn't use simulation at all and you had a test track. It's not feasible, even in that environment, no matter how many of those scenarios you think of. So there's disadvantages of using software to test software. And that's really what simulation is.
How does it change when you have a public customer, Toyota, and they're going to operate their autonomous vehicles in Japan, and you have another public customer, MA Mobility, operating in downtown Detroit? How does the simulation change, or do the scenarios change? Can you shed some light on that, since there are two different driving styles in different countries with rules and regulations?
Yeah, so there are actually many things that change when simulating systems in different geographic areas. As I mentioned earlier, there's also many different types of simulation. And so those nuanced changes actually are different for each of the different types of simulation, depending on which part of the system you're focusing on developing. But just to give some examples, certainly street signs are different in different geographies. The types of lane lines that are used in different geographies are different. The way that traffic behaves is different. And generally
when pedestrians behave on the side of the road or interacting with traffic.
Absolutely. So all of these different things that are different in different geographies can be modeled in simulation. And in fact, within our product, we do have different presets or defaults that can be used to simulate different types of situations. And certainly there is a pretty big difference between the Japan freeway system and the Detroit urban use case.
How do you get the initial data for driving habits and patterns from where your customers can operate? Does that come from your customer, or do you send a team out to that local market to study and to learn it?
It depends really on the situation and the customer. There's many ways you can essentially extract behavior models. You can create them. You can extract them from real logs. There's a bunch of different ways. And what happens like in a mining use case is very different than, I think we always default to urban robotaxi. That's just one version of that. So there's a lot of research written on this, and there's a lot of different methods that you would employ. But maybe another way to kind of think about this is if you were trying to learn, let's say, like photography, and you're going to have, landscape photography is very different from street photography, is very different from product photography. So even these behaviors themselves, what they are, how you extract them, how do you do parameter sweeps on those behaviors, all really depends on the specific operational design domain of the customer. There is interoperability for some of those behaviors between different customers, but not always. And so it depends really on the situation.
Really interesting, because you're a diverse company, and Qasar, you've got one really interesting, diverse background. I listened to a great podcast, the Kleiner Perkins Go-to-Market Grit podcast, and you spoke about the importance of diversity of skills. I think it's extremely important. And I had no idea you were exposed to automotive at GM, software at Google, and venture capital investment at Y Combinator. I think it's super cool. You got all the pieces of the pie to make something really special, what you're doing with Peter at Applied Intuition. How are all these experiences impacting the way that you operate and run Applied Intuition on a daily basis?
Yeah, I mean, fundamentally, I think for, every listener who's trying to build a company or is thinking about starting a company, I think the heart of at least software companies is really, really great products. And you want to figure out how to be a great product person. And that, comes from my and Peter's, frankly, backgrounds, or we have technical backgrounds, and then we practiced as product managers at multiple companies. So we've learned a set of skills. So I think if you're starting a company, that's one of those important skills you need to have, which is how do you build a product? And then, the other things, like I think YC is Y Combinator, colloquially known as YC, is a great example because YC funded, Cruise automation. We're the first check in Cruise. And Cruise, we've talked a lot about Waymo, but Cruise has made a huge impact in the ecosystem as well. And so seeing, that company from when it was just Kyle all the way through the acquisition at General Motors and beyond, I think is just incredibly informative about how to build a company. And so I think all of those things, and of course, working at GM, and I went to undergrad for listeners who don't know, I went to undergrad at the General Motors Institute. So I really, really deeply in the auto business. The joke that, Peter and I sometimes make is, we forgot more about the car business than a lot of people know. Just because, Peter's a third generation automotive engineer. I went to GMI and worked for 7 years in the business. So all of that, they're just ingredients. I don't think any one ingredient is going to build you a great company, but I think putting them together in the right way, I think has enabled us to build a good company. I don't think we're anywhere near the conclusion of this story. And I think beyond all of that, putting all those ingredients, I think we've just been very focused. We focus on tooling. I think it's a classic problem that a lot of high growth companies make is their appetite is much larger than their ability to actually execute. And I think if you read enough about great companies, you start thinking, well, I need to have this massive idea. But, when you look at the early days of Microsoft, of Apple, of NVIDIA, they're very, very different companies than they are today. Now they're like a multi-product massive companies, but they originally started in the first 5, 10, 15 years of their lives as very, very focused companies. And so I think that's kind of like all of the ingredients plus focus, I think has been the thing that's kind of worked out so far. We knock on wood, we're I think extremely paranoid about making mistakes. And I don't want, the listeners or even, our own team who else ends up, listening to these podcasts to think that we somehow can start celebrating because we've had a couple of good innings. We're still a couple of innings into a very long ball game.
I like the way that you manage the company because you're hungry and you're still hungry and you're continuing to constantly innovate and stay focused. And I'm happy you brought up Cruise. I've known those guys from back when they had the retrofitted Audis and driving around San Francisco, and they were highly focused. And back then I was the co-chair of the Tom Siegel Task Force of the City of Beverly Hills, and we'd call up Kyle and the lawyers up there and say, "Come on, guys, go down to Beverly Hills. Come on, we want you to test down here, and we'll help you with the regulatory environment." "No, we're focused on San Francisco." "No, just come on and we'll have lunch." "No, we're focused on San Francisco." And it was that incredible with Kyle and the team had that and Matt Gipple, who was the attorney at that time, had this incredible focus on executing a great product. And I want to say today they're a great company, and with Dan Ammon, former GM gentleman, he's running that company incredible, better than most individuals who run these companies because he's focused on commercialization and he understands the markets and has a very similar background to yours. And I can't wait to see when you get to Cruise size how you're managing that company, because I got a feeling you're going to do a really good job when Applied gets that big. Peter, shifting gears to autonomous trucking now, which I'm calling, we're in the midst of the great pivot to autonomous trucking as robo-taxis enter the autonomous trucking space. What are the main differences between simulation for autonomous vehicles that are mostly going to run in dense urban environments compared to autonomous trucks, which will run on the nation's highways? There's
many differences. In fact, they are quite technical. Just to give some examples of the technical differences, on a truck, of course, you have much greater limitation to how fast can you accelerate, how fast can you decelerate. The sensors are located typically in different places. So in a truck, you might have actually better visibility going forward because the sensors can be mounted higher up and just have a better field of view generally. But you'll have worse visibility looking backwards because the trailer of the truck will actually block typically sensors on the back, unless you are able to mount sensors on the trailer itself, which I would say is unusual. So each of these things have to be taken into account in simulation. And furthermore, the way that trucks would handle dangerous scenarios are typically quite different because of these limitations than an urban robotaxi system. Right? If a truck has strict limitations on how fast it can actually decelerate, given that it maybe is carrying 80,000 pounds in a trailer, it's going to have to take a different type of evasive maneuver compared to let's say a robotaxi that's only going 30 miles an hour and can more or less brake on a dime. So each of these differences, although it may sound not too complicated, is actually incredibly complicated when you get into the details. And there's a pretty large difference between the fundamentals of the systems when you're looking at truck system versus an urban system. And luckily, our simulation environment works great with both of those use cases. And in fact, we have customers that are doing both trucking and as well as urban robotaxi systems.
Qasar, you've clearly thought this through and alluding to something earlier. And in an August 11, 2020 Medium post by Kodiak Robotics, the autonomous trucking startup who happens also to be a client of Applied Intuition, the company stated the following: "Rather than spend millions building our own simulation platform, we instead chose to partner with Applied Intuition, one of the leaders in this new industry. Unlike some simulation tools, which were built on top of platforms designed to generate images for movies and video games, Applied's system was purpose-built for AVs. We think this makes Applied one of the most flexible and powerful simulation platforms available to anyone." This is a big, bold statement from a leading autonomous trucking startup company. Again, the company's got great management with Don and Jordan and everybody over there. Why did you make the decision to focus solely on autonomous vehicles and not divert to other forms of simulation?
Yeah, I think it's such a vast field of simulation, and I think so. We talked about focus earlier, but I think fundamentally we think the autonomous industry will be very, very large, and we believe everything that moves will be autonomous, and we want to enable that reality. And I think that's the wave that we're riding in. I think a lot of times, especially when you're it's kind of like the stock market. If you zoom in, you see the volatility of the day, but really you have to zoom out. And there is no version of zooming out from 2000 and let's say 15 to 2030 over that 15-year time horizon that we have a lot more autonomy. Just in from 2015 to now, the growth of Tesla Autopilot and GM Super Cruise, who arguably is actually the leader in the space, and then you have a bunch of other players, ProPilot and Pilot Assist from Volvo, et cetera. We are seeing autonomy more day to day, but I think in the industry we focus a lot on like the Waymo milestones, the Cruise milestones, and then a bunch of other companies like that, rather than kind of zooming out. And I think if you zoom out, you see autonomy is a big and massive market. And I think if we can make a focused dent in that market, we've made an impact. And you don't have that many years in your life, so if you can do one really great thing and make a impact in one industry, I think that's as great as it can get. So that's why we think it's a pretty big field.
Hit on a lot of things. You're going to not have an impact on your employees and your investors, but you're going to have a positive impact on society because, as you said, everything that moves will be autonomous, but it's also going to make our roadways safer. And that's the technology you're developing. On the stock market, you're 100% right. There's no S&P 500 index for us to track for autonomous vehicles. One day in the future, when we look at that, we'll get there. And you're humanizing what you're doing. And it's really special how you're stating all this here on the podcast. And Peter, when you're developing a system for autonomous vehicles, how does that differ from the systems that are designed to generate images for movies and video games?
Yeah, they're really quite different. Movies and video games fundamentally are about what looks good to the human eye, right? Like what's sort of, let's say, pleasurable or fun to look at. Whereas we care much more about how real is it to the robot, to the robotic system that's actually powering the vehicle. And so that means we care a lot more about physics. We care a lot more about determinism. And fundamentally, the way that robots see the world are very different from the way that video games or movies are done. Just to give one example, LiDAR, of course, and radar are very common sensors on these systems. Those sensors are operating at very different wavelengths from visible light. And the way that those different wavelengths of electromagnetic energy interact with objects around them, fundamentally, it's very different from the way that visible light interacts with objects. And so in order to simulate those accurately, that means our simulator has to be built around the fundamentals of the physics of those different wavelengths. And so they're really quite different systems at the technical level.
Peter, following on that, how can real-world driving data improve simulation?
It's critical, frankly, to a great simulation environment to understand real-world driving data. So I'd say it complements it. You can't really have a simulation environment fully in absence of real-world data because you do need to make sure that fundamentally the simulations are going to be accurate. And the way that you verify that a simulation is accurate is you have real-world data, and you can run a simulation and see if you have the same results as that real-world data. So I would say it's fundamentally, there's always going to be somewhat of a gap between simulation results and real-world results, but using real-world data, you can narrow that gap to such a small amount that you can nearly guarantee that your simulation results are going to be representative of the real world.
That's fantastic. Qasar, staying on your everything that moves will be autonomous theme, what new verticals is Applied looking to enter?
So we're already in a bunch of other verticals. We've mentioned some of them, but mining, construction, AMRs and mobile robots in warehouses, defense. There's lots of verticals that are working in automation. Everything from, forklifts in factories to luggage movers in airports. These are all will ultimately be autonomous systems. And we hope to provide support to all of them. And a bunch of them we already do, frankly speaking. I don't just randomly come up with those industries. They usually are at the top of mind because we were talking about a customer, earlier today or something like that. But yeah, I think there's a huge diversity of autonomous applications, and I think that's only going to grow over time. I don't think that's getting more narrow.
I agree with you. There was an interview, I think it was last week in the Wall Street Journal with the founder of Prologis, the warehousing logistics company. And he clearly stated that they're all in on automation for their warehouses and making it better for their commerce, as e-commerce is predicted to grow 18% again this year. And Steven Schwartzman and John Gray from Blackstone continue to buy up warehouses at record numbers. I fully agree with you that automation is going to play a critical role because not only is automation going to improve it, it's going to help shore up the supply chain so those goods can get to individuals faster, cheaper, and more affordable. Peter, from a technical perspective, How does this change your approach? Do you have to kind of look at each different segment for the simulation? Or can you shed some light on that from a technical perspective, please?
That's a great question. So I would say lucky for us, physics is physics. So when we do something physics-based, that will translate perfectly generally across whichever vertical that it's applied to. There are certainly aspects, though, where you do need to make simplifying technical assumptions to get great performance for a particular type of simulation. And in those cases, we will need to tweak different technical approaches for some different verticals. But I would say vast majority of the work that we do applies to all verticals. And only a small subset of things are custom tailored to specific verticals.
Qasar, as you said earlier in this podcast, you're merely in the second inning of a long game here. In October 2020, Applied closed the Series C round, raising $125 million with a $1.25 billion valuation. I got to know, you gave the baseball analogy. We're still in early innings here. What's next for Applied?
Yeah, I think, we talk about this internally often and frequently. A handful of things that are kind of on our minds. And, and the company isn't just Peter and I. We're a whole group of professionals. And I think it's sometimes strange in the AV business and in startups in general where there's such a focus on the founders. It's like, this stuff is not coming out of just Peter and I. This is coming out of a large team that has lots of different and varying skills. But I think, top of that list of things that we talk about is how do we maintain product leadership and category leadership. We have a little bit of a gap between us and the others in the field, but we are in a competitive environment and we want to be the best. And I think so not only in terms of category leadership, like within the markets, but also technical leadership, right? We want to be pushing the envelope because we can invest dozens and dozens of engineers on individual topics that no in-house team would be able to because it's not their business. Their business is something else. It's getting autonomy systems to market. I think our focus, as we've talked about the theme a little bit of the podcast, the focus on tooling, I think has been great. And I think there's a lot of more to go there. I think the larger you get, some of the economies of scale start coming in. So as we get more and more mature, it's cheaper for our customers because we're distributing the costs, even though we're a larger and larger team across more and more companies. And so now our customers today get way more than they would have even a couple of years ago and cheaper. I mean, that's a fantastic outcome for everybody. And that's why capitalism works, right? You're distributing costs across lots and lots of groups of folks. And everybody gets something better than they could do themselves at a cheaper price, which is fantastic. And so I think us kind of staying there. I think growing our global presence, I think has always been a priority for us. And we continue to do that. We have a bunch of offices already. So, today we're talking from Mountain View and we started Detroit almost right when we started the company, kind of where Peter and I are from, but we have a presence in Munich and we have a presence in Seoul and we have a presence in Tokyo, like not, random cities right there. I don't know when we'll be in Palm Beach. I'll be honest, that might be a little bit, but we continue to grow where our customers are and supporting them in an effective manner. But yeah, the reason a company like ours raises capital is to do more of what we're already doing. Rarely are you getting to this stage and still trying to figure out what should you be doing and what should the business be. There obviously are exceptions. So I think we want to do more what we've been doing and provide even more value to our end customers.
What you're doing is creating value. And it's clearly validated from your customers in the marketplace. It's clearly validated from your tier one investors. And gentlemen, we've covered a lot of ground on this podcast. Peter, I thank you so much for shedding a technical light on simulation, and for Qasar sharing the business of simulation. And gentlemen, as we look to wrap up this insightful conversation, what would you like our listeners to take away with them? And Peter, I'll start with you, please.
Yeah, I would say that there's many different aspects to developing autonomous systems. Of course, you have the hardware itself, you have the rider experience, training algorithms. Frankly, as Applied, we don't know everything, but we know simulation really well. And this is our area, and this is where we can have an impact on the world.
Qasar?
Yeah, I think even conversations like this that might be half an hour, 45 minutes long, we're scratching the surface in the most extreme. Simulation itself is an incredibly deep field, and AV simulation is. We could spend. I mean, we as a company have done 8-hour demos on one part of a product, right? Where you're really getting very, very deep. And so it's not even an appetizer. It's not even looking at the menu. It's like looking at the tag on the Google map listing of simulation. There's so much more that we talk about, and we love talking about it. So, my self-interested plug is, If you want to learn more about sim or AV in general, we can certainly help there. Obviously, the tooling is our expertise. And then on the point of raising money, frankly speaking, we're hiring. Applied.co/careers. We're hiring really across almost every role in every office. So if you listen to nothing else and you're interested in the field and you're an engineer, the message is we're hiring.
You're going to work with an incredible team of individuals, not just Peter Qasar, but the entire team at Applied. It's a really great company that is going to have an extremely positive impact on the future. You're going to create meaningful value for society. So I highly recommend you visit applied.co/careers if you're interested in a job opportunity, or if you want to geek out on simulation, please visit applied.co. Because as we've heard today, the future is bright, the future is autonomous, and the future is simulation. Peter Qasar, thank you so much for coming on here as we scratch the surface of simulation today.
Thanks for having us.
Thank you.
Thank you for listening to the Road to Autonomy podcast. If you've enjoyed listening, please rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter at Road to Autonomy or email podcast@brulteco.com. The Road to Autonomy is produced by Brulte & Company. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect the views and opinions of Brulte & Company. The content discussed on this podcast is for informational purposes only and should not be taken as legal, tax, investment, or business advice.